Welcome back. My name is Ted, and we are doing the unofficial Handmade Hero platform layer for the Mac. Uh, it's starting to get late. I had a few failed attempts at trying to record this video. Overall, where we're about to venture is sort of a pretty complicated kind of space. But suffice it to say, I feel like it's better to just kind of drop right into it because I think my energy level will just probably diminish if I spend too much time belaboring the point or just dicking around at startup. So here we are. So we on the last session, what we did is we got a square wave playing, and we did that by using this render callback, and this thing gets called by Core Audio pretty frequently actually. And all it's doing is it's outputting this square wave that I showed you last time. So if we play it, it's fairly harsh kind of a sound. So we go back to here. Let's see. So we have a different one actually. So yeah, day 10. So it's the sound. Ooh, that's bad. That's the really high-pitched version, clearly. But the idea is it'll play the sound for us. And I think I probably didn't do the best job of explaining what's going on here. So I said that I said that when the running sample index divided the remainder of it when it's divided by the period. When it's greater than a half period, so if we're going halfway across this wave, I said that we'd switch channels. Like my wording wasn't quite right. What I really meant was that we would switch from peak to trough in the wave. So when it's greater than half period, then we use the positive side of the wave, and when it's not, we use the negative side of the wave. So I just kind of wanted to clear that up to get started. But now I think we're actually going to move into the proper sort of way to do sound for a game. And if we're looking at so in Handmade Hero for Windows, just to even get started to talk to direct sound, you have to allocate a circular buffer. That's kind of the API that Casey chose. We're using Core Audio, which is a little bit different in the way that it works. You just saw that Core Audio does not really require us to set up a buffer or anything like that for the sound right away. We're actually able to just directly, throw some, slam some code in and have it get handled programmatically. So the Core Audio API, I just want to highlight that difference. That in Handmade Hero, the first thing that Casey does is he sets up this 2-second buffer. So there's 2 seconds of audio here, right, and 0 seconds, and you're kind of that's our memory for the audio buffer. Just to even be able to get started with direct sound, you have to do that. You have to create these this primary buffer and the secondary buffer. You saw in this series that we didn't have to do any of that just to be able to get some sound out, just because the Core Audio API that we're using is quite a bit different in nature. And so that's kind of an important thing to point out. So we actually have to, but the interesting thing is we want this circular buffer sort of a behavior, right? So we actually want this sort of a thing where when we get to the end of this, then it just kind of, the system will wrap around. And so instead of Core Audio just creating that for us, at least to my knowledge, again, the documentation that I found on it is pretty sparse. I haven't really found anything that has kind of a similar API sort of style to what Casey uses, where we just give it a 2-second buffer and then we can do kind of system calls on it, where we can ask it, okay, well, where were you last when you, so we'll say this is the play cursor, right? So what this is in terms of sound is this is where the sound card is actually last played from, right? And then maybe this is the right cursor, right? So this is where actually no, wait, we don't want, I think it's I'm sorry. That is not what I meant. Let me get rid of this. So maybe, maybe then the actual right cursor, sorry, it's a head usually. Maybe where we last wrote is like a head. And so on the Windows system, you're actually able to kind of like, you're able to query this. So I'm able to ask it, through some kind of a system call. I can say, hey Windows, where did we last write to this sound buffer? And it'll give me some offset, right, within that buffer. Or it'll tell me, okay, where did you last play from? Where's the sound card actually playing? And I can get the play cursor from that sound buffer that was handed over to Windows. On the Mac, it's very different because what we're doing is, like, we actually have direct access to this sound buffer that we are creating. So we're the ones that are like passing. What we're going to do is we're actually going to pass by reference a pointer to this sound buffer in the actual audio render callback, and then we're going to, instead of the API or the Windows telling us where the play cursor is, we're the ones that have to actually manage our own play cursor. So it's a little bit different, and I honestly don't know to what degree it's even accurate. Again, this is kind of like the best way that I was able to find out how to kind of get something up and going, given fairly sparse documentation. So far as I am aware, obviously I would expect somebody to kind of come in and correct me on this because I'm probably wrong. But so far as I'm aware, with Core Audio, I don't know of a way that I can do this sort of like hand them over a circular buffer, have them manage that, and then give me some kind of an offset into it, or like let me know where the play cursor is. All I get, so far as I understand, are these like pretty regular audio callbacks that we can then use to read from this buffer, and or rather so we're going to get these same regular audio callbacks that we get right here. This thing just occurs with certain regularity. Instead of just outputting programmatic sound for us, what we're going to do is we're going to have it read from the circular buffer, and then we're going to advance our own play cursor in that buffer, so that we ourselves are managing that. And then what we'll do when we're about to write to this buffer, because if you watch the series, right around, the explanation is probably better than what I'm going to be able to give kind of like late-ish in the night for me when I'm, just trying to like splat this out when it's as fresh as it can possibly be in my head. The idea is that wherever this play cursor is, we want to write, I'm actually going to, let's delete this. We want to write a little bit ahead of it, right? So maybe what we want to write is like here. So I'd call that like the target cursor, okay? And the idea is this is where our last callback from Core Audio left off. It left off when this thing got called, it left our play cursor here, right? And so when on the next time we update the frame, we want to write some amount ahead of it, so that the next time Apple or Core Audio comes and calls us and starts playing sound, it plays up to this place, up to this target cursor where we wrote to. And then that way we can be about as synced up with the sound system as possible, And again, I don't know exactly how accurate, how close, in terms of frames, this play cursor really is, because all that we know is that this thing gets called, right? And you see that in this function here, our render callback, we're getting the audio channel that we're writing the data to, that we're writing the sound to, but we don't really know when that plays. So we can't assume that when we put values into this channel, or into this buffer here, that it's getting played immediately. So we have this, it's a little bit, it's a bit sloppy because it's like we can manage our own play cursor in this in our own circular buffer that we ourselves make up, but we don't actually know if we don't know that necessarily, well, it almost certainly doesn't. It couldn't, right? So when this thing gets called, like, and we advance our play cursor, there's really no way that that is going to be immediately read right away. So there's unfortunately, the way that this is set up, there's a little bit of slop there, and it's not ideal. Obviously, it's certainly. I think there could probably be a better way, and there probably is a better way, but I kind of, I thought about, okay, well, do I want to present this or not? And what I got to thinking was, this is better than nothing, right? So if I guess I just, I'm kind of allowing like the goal of this series to sort of guide me in the right direction as to what approach to take. And if the goal is to just get you started and up to speed and following along with the series, then I feel like taking this approach is actually okay, because it'll be good enough for you to follow along and have the code be roughly pretty darn close to what is actually done in the series. And then later on, in your own time, if you want to try and find a better way to do this, maybe find a way that is more similar to the Direct Sound API or use a different API or something else, you'd be able to do that. So I think this is, like I said, it's not ideal, but I think it's better than having nothing, and it gives you something like a starting point, and kind of once you're going in this direction and sort of regularly practicing this kind of low-level programming, I think you'll just be in a better space to start doing a lot of this stuff on your own. So that's kind of the decision I came upon. So anyway, with that said, hopefully that's been a good enough introduction. Like I said, a lot of the videos are pretty good, but there are a lot of the explanation around handling sound. I thought it was great, but it's also just such a challenging aspect. This is probably the most challenging part of the platform layer in my experience, and I say that having done like the hot loading for the code and the virtual memory game state recording thing that comes later, and there's a lot of really cool stuff. But I actually thought that just wrapping my head around the audio ring buffer stuff was probably some of the most difficult. So bear with me, it's difficult, but we'll try and do our best and just kind of work through it. So there we go. First things first, we actually want something that's going to hold this this state for audio. So what I did is I made a struct. So actually, I'm just going to pull that up. So what I did was I just made something to kind of encapsulate all of the max side of our audio output. And so we're going to do that. And so I just want to walk you through what this is. So max sound output. And then, yeah, so another thing too is we want to, and we'll get to that later. So we're gonna make this thing called max sound output, and all it is just a structure that kind of hangs on to some of the state that we care about for doing our own circular buffer. So because we're not using direct sound and we're kind of rolling our own circular buffer, that means that we need to kind of keep track of some of the state that's related to it all on our own. So we're going to hang on to the number of samples per second, right? And in that case, that's the 48 kilohertz samples per second. Bytes per sample, that is, we know what that is. That's just 16 bits per channel, right? Times 8. So, or I mean, sorry. it's 4 bytes. It's 4 bytes because it's yeah, 2 bytes per channel. So that's the idea. So one sample is 4 bytes. And then the buffer size is just going to be the number of bytes per sample times the number of seconds of samples. Yeah, so times the samples per second. So that's going to give us that 2-second buffer. So whatever this amounts to in terms of bytes, that is a 2-second buffer, and we'll set that up. And we're not doing a write cursor, so I'm getting rid of that because a write cursor doesn't really make much sense with our setup. And the reason is because we know when we know when we wrote to it, but what we have is like a simulated play cursor. Really, what we have is something where it's like we know when maybe I'll just make a note here, something like this isn't the real sound card play cursor, right? It's just the last time. It's just the last time Apple or Core Audio / Apple called us, if that makes sense. So it's as far as we got the last time. It's as far as we got in the circular buffer here, the last time that Apple called us. That's really what that is. So, and this is kind of what was so difficult about doing this on the Mac, was like trying to fit this model of how it was done on Windows to how it's done here, and it's really not even the same. And so, and then if you kind of look at the Linux tutorial, that's very different too. So it was just this matter of like saying, okay, well, what do we really have here? What's really going on? And what we really have is kind of it's like a simulated play cursor. It's not exactly a play cursor. So, and then we've got this void star data. This is the actual buffer. This is the actual circular buffer that we'll be reading the audio from. So just kind of putting that out there. So we'll be using that. And then this just hangs on to that pointer to our audio component instance. So that is the same this same pointer that we passed here. So all we're doing is now instead of passing in this setup audio function here, instead of passing a pointer to the audio component instance, we're going to pass a pointer to Mac sound output, right? So that's just our platform-specific sound output structure, right? So let's do that. Just for the, kind of for the purpose of being fast, rather, I don't want to get too much into writing a bunch of this, going over code that was written or anything like that. So I'm trying to save some time. So I'm just actually going to probably copy a little bit more code in than I would otherwise, just because I think the explanation part is actually going to be a lot more valuable here. So we're going to go back to where we set up the sound. So, and also because I just wrote this. So let's see. So this part, this audio component, that's all going to move. And I'm going to open up my other the code I was working on just earlier today. So let's see. Let's quit that. All right. I actually ended up rewriting all of this because there's a lot to it, and I don't know. I wanted to make sure that I understood it a little bit better before trying to explain it. So let's go back to this Mac setup audio, at least on this version. All right. And yeah, so there's a lot that's going to change here, but this is the important stuff that I want to copy over. So Mac setup audio. Okay. All right. So first things first. So yeah, just to give some context, first thing we do is we create this sound output structure. It's just a Mac sound output. No need for it to be global or anything like that. It can actually just live at the scope of the main function. And then we just pass a pointer to this thing. So we're going to do that. And first thing we're going to do is we're going to set up the samples per second. That's just the same as that 48,000, right? Audio frame size here is actually just the same as this, as the bytes per as the bytes per sample. So you'll see this bytes per sample is just audio frame size. And so what that means is you know, now that we've kind of consolidated some of that logic for the sound output or the Mac platform layer sound output stuff, we can just put that in. We can just use this later on when we set up our audio descriptor. So we're going to go back down to this audio descriptor and just change that. Oops, wrong platform layer. Oh gosh, I hope I'm being, yeah, okay. This is a problem when I've got all this code that I'm like copy pasting. Okay, yeah, so audio frame size, yep. And what I want to do is go down here. You see this bytes per frame. So now that is actually sound output, right? Bytes per frame. No, bytes per sample, sorry. Sample frame, same thing. Okay. All right, and then bits per channel, that's the same. So yeah, so all I'm saying is we don't need that anymore. And then the sample rate thing is just the same as sound output samples per second, right? Excellent. So number of seconds, 2 seconds, that's what we want, right? Bytes per sample. So this is where we actually do the allocation for the buffer. And the 2 second sound buffer. So like I said, the buffer size is going to be the number of samples per second times the audio frame size, right, 4 bytes, times the number of seconds. So that's going to be just total size of this buffer in bytes. We're going to use that to sort of figure out where we are in terms of where we've been playing the sound. And then we just straight up do a malloc of that. So that's now that's our pointer to the data. And then the play cursor, actually we're not using a right cursor, so we don't, because it doesn't make sense. So this sort of simulated play cursor, this position that represents where we got to where we progressed in terms of giving data to giving sound data to core audio the last time core audio called us, right? That's what this is. This, I say play cursor, but it's really more like a simulated play cursor. We're just going to set that to 0 to start off, right? So, and then we initialize our audio unit, and I'm sure some of this other stuff is wrong, so I'm going to look at, gosh, if I do that, I'm going to be super confused. I'm not going to do that. I just want to make sure that all my, okay, so that's sound output, audio unit, okay, because we're not passing that. And then just all this stuff changes because audio unit is now on sound, it's on this sound output structure. So the pointer to it is a little bit different. So we're going to go back through here and then setting up our audio descriptor, different flags, channels per frame. This is all the same stuff that we did earlier. And then what I forget, I think I actually just do star sound output audio unit. So we go through that, same thing. Star sound output audio unit. Okay, render callback. Okay. Now you just got to remember what we did at the very end there. Okay, yeah, so it's the same thing. Okay, gotcha. Let's just do this. Like I said, I don't really want to, spend much time kind of belaboring all of this stuff, just the sort of boring stuff. So we got that. Let's see if we can build. And that builds day 11. By the way, for those watching, this is not actually supposed to line up with Casey Muratori or with the actual Handmade Hero, just because I found that trying to get them to line up is just not really going to happen. Like, it's just there's just no way. So this is like roughly like day 8 or so. Just it's different. It's a different platform, so that's fine. Okay, so that compiled. That's good. So now we're not really going to use our square wave render callback. So what we're going to do is we're going to do something very different. And I'm going to just copy what I had here from. We're going to use this core audio callback. So 375, yank that. Go back up here. Okay. And this is going to seem pretty, well, let's see. Okay. So yeah, down here. I'm just going to get rid of this because we're not really going to use it. So this is that same, it's got the same kind of signature as the other callback, right? It's just that we call this something different, and we're doing slightly different things with it. So that's something kind of worth noting. First things first, we're actually passing in a pointer to sound output. And we haven't done that yet, but I'll show you where we're doing that. So we have our sound output. And all we're doing is we're just taking this in refcon, this void star that gets passed in here, and we're just casting it to our max sound output struct. Okay, and so then we're going to use that sound output. This thing gives us the pointer to the actual circular buffer that we're gonna have core audio read out of, and then as it reads out of that circular buffer, it's going to advance our sort of simulated play cursor. That's sort of like our best approximation in terms of where we understand or where we think the sound is actually getting played to, or was last played. So that is how that is. Where do we pass that? That's a great question. So happy that you would ask that. I could probably slow down a little bit. So this we pass that in this input proc refcon. All we do is we take our sound output struct that we passed in here, and then we cast it to a void star. So we're going to do that. I'm going to go back to our max setup audio because we haven't done this here. So right before we set up, so we set the input proc refcon. That's the same thing that gets passed in. This is actually, if you look at this, when we did the video game controller setup, like setting up a Sony PlayStation controller, this is actually really similar to that. You remember how there were like just extra kind of slots that were left open for different void star parameters that we could just, if we just took a struct or whatever and cast it to void star and then set it on that. It's pretty much the same kind of a style of doing things, which is sort of more of an old school kind of C way of passing parameters into something. So and then we just have to call this something different. So we're calling it core audio render callback, right? And then that ought to be it. So we've actually passed our sound output struct into there. So that part's taken care of. Pretty happy. But now I actually kind of want to walk through this code of what we're doing, right? So when this thing gets called, what is happening here? We walked through this a little bit in the previous video, but we'll just kind of go over it again because I'm just trying to instill as much of an understanding as I can. So this in number of frames that gets passed in, what this is saying is core audio is about to play, at least so far as I get it. It's like calling us and saying, it's like saying, hey, we're about to play this many frames of audio, okay? So give us this much frames of audio. This is what we want, right? And so we are getting the number of frames, but that is not exactly in the language of the circular buffer that we just allocated, or that we're going to be reading from. We want to put this not just in terms of frames, but we actually want to put this in terms of the number of bytes of sound that we're going to be outputting, right? And what that's going to do is that's going to give us sort of the right offset into this circular buffer to figure out kind of how much to advance the play cursor when this is done, so that we have a fairly accurate sense offset into this circular buffer and can properly read from it. So that's what's going on. So this is really just the raw total number of bytes that we intend to give to core data to have it play, right? Or it's not core data, core audio, to have it play. Sorry, things are bleeding in from my job. So the first region so what we're actually trying to do here is simulate or get something that is kind of like an approximation of the Windows API with a circular buffer. So if you watch the Handmade Hero stream, the Windows one, there's this idea of the region 1 size and the region 2 size. And what's going on here? So I'll do another kind of diagram, right? So I've got this, right? And like let's say that when core audio calls us, right? Let's say that our play cursor is like here, okay? Right? And then and we're actually at the end of this buffer, right? And then the total number of bytes that it wants to play it goes past the end of this buffer, right? And so what needs to happen is we need to like wrap around, right? Oh god, my pen is just as crappy as Casey's. Okay, so this thing runs. So this thing is gonna like run all the way around. So there's this extra remainder, right? And so this is region 1, right? And then this is region 2, right? And so what's going to happen is instead of us just reading up to here in this case, what we're actually going to do is we're going to wrap around, right? And then we're going to start at the beginning and we're going to read to here. We're going to read from this circular buffer, and then we're going to supply. So we're supplying stuff to core audio, supplying stuff to core audio, wrapping around. And so this region 2 is actually over here. So what we're doing is we don't, Jesus, what is that? This pencil tool is terrible. Anyway, you get it. This is I was trying to draw a 2, but I guess I can't just draw a 2. Anyway, so what we're trying to do is this will wrap all the way around, and then we'll have this kind of extra amount of bytes of sound that we're going to be giving to core audio, right? So that's kind of how that works. So that's us because we have a different API here, and we're trying to make the API. I sort of felt like a goal for following along was to try and get the API to be as close to Windows as possible, so people that are starting off could just follow it. And so that's the idea. Is I'm trying to kind of mimic these like region 1 and region 2 that are in the Windows API. And so that's kind of what's going on. So when we do this, we first assume, because it is possible that, like, let's say for example that, all right, I'm just gonna like, jeez, this is so bad. I'm going to just make a new one because I don't like this. So I'll make a new sketch. Don't get me wrong, I actually like Sketch, but it's just, I don't know. So make a new one. So it's entirely possible that this play cursor is like right in the middle here, and like let's say that this is the number of bytes to output, right? So we're going to output this many bytes. Well, in that case, there's region 1 is just the total amount that we're going to output. It's actually not. It's actually not anything like, there is nothing in region 2 because we didn't wrap. So region 2 really only applies to a circumstance in which we wrap all the way around. So that's an important thing to know. So region 1 size is, so we're gonna just, the way we're gonna do this is we're just gonna assume that we are going to output the full, that we lucked out, we're in the middle of the buffer or something, we're just gonna output the full amount. And say that it's 0 for region 2. But then what we want to do is we want to handle the case where we wrap, right? So if where we are, the play cursor, right, this kind of simulated play cursor, the place where we last left off when this thing got called, if that plus the amount that we're about to output, so this is just what we're checking is, we're checking, did we write, are we about to write off the edge of this circular buffer, right? That's kind of what we're asking. So if it's greater than the buffer size here, right? So in that circumstance, then what we want to do is we want to modify the region 1 and region 2 sizes. We want to modify them so that the region 1 size goes to the end of the buffer, right? That's buffer size minus where the play cursor is. That goes all the way. That's the amount where if we wrote up, that's the amount of bytes to the end of the buffer, right? And then the region 2 is just the slop, right? Like whatever's left over. So total amounts to output minus the original region 1. So that's just the remainder basically, right? So then what we're going to do, this is probably not the best way to do it, but this is kind of how I did do it. Maybe there's more of an incremental way, but we're gonna do a mem copy. So we're just copying from where the data currently. We're going to take. We're going to copy at. How shall I put this? We're going to take what is, so we're going to write to the to this memory channel here, to our output buffer, from where we're going to write up to where the play cursor is. So what I believe this is saying is, so this is actually the start. Sorry, I don't use this too often. This is saying where do you want to start getting the data, right? So it's like a pointer to where the bytes are that you're going to copy. So this is constant, this data pointer, right? That just points to the beginning of the sound output buffer, our circular buffer, plus wherever we are in the play cursor, right? And that represents our region 1. Okay, so we're just going to straight up copy those bytes to this output, to the Core Audio's output channel. Okay. Then what we're going to do is we're going to now what we're doing is the starting place of where we're going to copy to in Core Audio. So this is, remember, this is the channel, is just the Core Audio channel that we were writing to earlier. We're going to start off at where we left off in terms of where we last wrote to, so just add region 1 size to it. And then in terms of where we're going to start writing data, we're going to start at the beginning of our circular buffer, and then we're just going to write the full region 2 size. Now, and that's because, remember, region 2, if region 2 ever exists, then it's going to be here, right? It's going to be at the start of the buffer. So there's going to be plenty of circumstances where region 2 is like no size at all, right? So region 2 is very frequently going to be 0 bytes, and we're not going to write anything to it. But in the case where there is this slop where we wrapped around, then we're going to take that region 2 amount, and we're actually going to write that to the audio output channel. Hopefully that makes sense. And then finally, all we're going to do is we're going to move the play cursor. So that's it. So this is just tracking, so we know how many samples to write into our circular buffer. That's kind of the idea here. And so all this is doing is it's saying, take where the play cursor currently is right now, right? And then add the amount of bytes that we output, okay? And then mod that by the size of our buffer. And what this mod operator does is, if the play cursor plus the bytes to output, if that ends up putting us in a situation where we're like past the end of this buffer, then what it's going to do is it's just going to wrap that offset around so that the play cursor ends up, where it should be, kind of going around the circle. That's all that does. So you'll see that quite a bit when working with circular buffers, is modding it modding some kind of an addition. Because now if I do this mod operator, then what I'm going to have is the remainder that's left over, and that's actually where I want to be. You know, that's the offset into the buffer that I actually want to be at. So that is just the same kind of core audio render callback that we've been using, but this time the only thing that's different is instead of reading from our programmatic sound, what it's doing is it's taking a certain number of audio frames or audio bytes, outputting them from our circular buffer, and then advancing the play cursor, and that's all it's doing. So this is just reading. This is just reading from our circular buffer. So if we're just reading from our circular buffer, then there needs to be some place where we actually do the writing to it. And the writing to the circular buffer is going to happen in the main app's run loop. So I'm actually gonna, I feel bad, but I'm gonna just copy some code because I want to explain this to the best way that I possibly can without spending a bunch of time just like typing text. And I really just want to get this video done like while it's fresh in my mind and I still have some understanding, and I feel like I'm at the peak of my ability to explain this right now. So, what we're going to do is we're putting the sound code right after the buffer draw and after the rendering the gradient, and this is going to change. So I just want you to know that this is going to change. This is not perfect. This is where we're putting it though, and we'll change it later. So, and that's right before all this controller stuff. So don't worry too much about all this stuff because, like I said, it's going to change, and there's a lot. There's so much going on right now that the actual order of these things is really not important yet. So I wouldn't worry about it. All right, so this is the start of our sound. Okay, and first, now what you'll notice is this is the same thing that we did for our square wave, right? So you have the frequency here, period, half period, and the running sample index. This local persist keeps the running sample index operating just as it was earlier with our core audio inside of our render callback. So that is going to start at 0 and just kind of keep incrementing up and up and up and up and up as this main run loop gets called. And now what we're gonna do. So the idea is we want to write some amount up ahead of the play cursor. Okay. So remember we keep. I'll draw this again. So we keep our play cursor here. So we have like some play cursor, right? And this is where we last sent sound samples to core audio, right? But if we're about to give this buffer some sound, we don't want to just write up to here, right? Like this, if we wrote up to here, we're actually, that doesn't really, that's not quite enough. Core audio might be somewhere else, but it would be better if we got ahead of it. So we want to get some amount of, I call it, Casey calls it the target cursor. We want to be some amount of samples ahead, right? We don't want to be too far ahead because if we're too far ahead, then we'll also have extra latency in the sound. But we want to be a little bit ahead of where that is. And so what we do is we figure out how many samples that is exactly. And so in this case, we have the number of samples per second. So maybe what we want to do is we want to be like a 15th of a second ahead of it. And so that's what this is this latency sample count is saying, okay, how many samples of sound would we have to write ahead of the play cursor to be a 15th of a second ahead? Okay, and so that's going to be maybe like a few frames worth, right? So we want some small amount of samples ahead of the play cursor where we're writing our sound. And then what we're going to do is we're going to basically just take this, and target Q bytes is just this number of samples ahead, sound samples ahead of the play cursor, that it is instead of having it in samples, we have it in bytes, right? So that way we know how that gives us like a proper offset into the buffer. And so then the target cursor, this is very similar kind of logic that we've seen earlier. We're going to take where we last know that we exported sound to core audio, and we're going to add in kind of this target, the target amount of latency, just to get a little bit ahead of it, small fraction of a second ahead of it, and then mod on the buffer size. And the reason we're doing that is so that our target cursor will also wrap around the buffer. Okay. And now the byte to lock just represents based on how far we got our running sample index the last time. We're doing this lock. We're doing this this way because we always want to start off at the last place where we left off in terms of getting the sound data that we're outputting. So using this running sample index, you imagine as we write more sound to this, the running sample index goes up and up and up and up, and that amount there, we want to always start where we left off, right? So if we didn't start, you can imagine if we didn't start where we left off, that would be a problem, because then the sound would have, it would cut out, it wouldn't be a continuous wave, right? So we keep this as a local persist, we have it kind of, we start off at 0, but then it whenever we come back into this function, this value is going to be whatever it was, whatever it left off at, and that is going to translate into some kind of an offset into this circular sound buffer, and that's kind of what's going on here. So that's going to be some offset into that circular buffer is where we left off last time. This is basically where did we leave off in terms of writing last time. So it's sort of like a write cursor, actually, if you think about it. So it's like the last place where we left off in terms of writing. And now what we really want to do is we want to figure out, okay, based on our target cursor, target amount of bytes we want to write ahead of this play cursor, how many more bytes do we want to, how many should we write? So we're going to start where we last left off, and then we're going to write up to a few milliseconds after where we last fed sound to core audio. So we're going to figure that out. And so stepping through this, if it's the same, so if for some reason we're right at our own target cursor, which I think happens at the very, well, no, actually, I'm not sure exactly when this happens, but in that case, I think we would actually want to write the entire sound buffer. So we would want to write the full 2 seconds of sound, because I think that would be the case where we're just like very, very far behind. But usually that's not going to happen. Usually what's going to happen is we're going to have two cases. One where we're ahead of the target cursor, which means that the play cursor almost certainly wrapped around. The only reason that we would be ahead is because the play cursor wrapped around, and we haven't, and our byte to lock hasn't wrapped around yet. So that would be this. That would be this circumstance here, and in that case, the amount that we want to write, this is kind of like region 1, region 2, right? So this would be like region 1, right? So region 1 being the end of the buffer minus where we are, right? So that amount. So like let's say that we're in this run loop and we wake up and our byte to lock is like right here, okay? So we can call that our right cursor maybe. And we have this much to go, right? But then we're also gonna, but our target cursor is like right here. You know, it's like, let's say this is our target cursor. So we're also gonna write up to our target cursor, okay? And so there's this amount, there's region 1, and then there's this other kind of region 2 that we're gonna want. So that code is for region 1, right? This is region 1. Buffer size minus the byte to lock. And then this is region 2, right? So wherever the target cursor, because if the target cursor is behind us, then the target cursor is just offset from the beginning of this buffer. So then we just add that in as the region, and that's the total amount of bytes that we're going to write. Okay. So this other amount comes down to being this is where we wake up and we're just I'm gonna get rid of this again because I just want to clear it out. So I'm gonna do it again. This is other circumstance where we're so let's say we wake up and like this is the byte to lock, right? And then our target cursor and maybe our play cursor is here, right? And our target cursor is here. So in that case, that's great. So we actually just have a single kind of continuous region in the buffer, and so that's what this represents. It's just because the target cursor is ahead of us in that circumstance, minus the byte to lock, that's the amount that we're going to write. All right. So that's figuring out how much are we going to write to this thing, okay? And then once we've figured out how much we're going to write, we know more or less what our region 1, region 2 are going to look like, and so we will then so we're going to take a look at that. So region 1 is just starting from the so region 1 is basically starting at the byte to lock, right? So that's starting here, right? In this circumstance, it could be another circumstance. We have the two other possible circumstances where the byte to lock is like right here, okay? That's another possibility, right? And then we have to wrap. So this is just saying get us to where the byte to lock is, and then that first region is just going to be total number of bytes to write. And then we end up modifying region 1 size. So this is actually very similar to logic to what we use when we spit out the data, the sound, circular buffer sound to core audio. So we have this size. So we're going to modify that if we wrap. And so this is the circumstance where if the bytes to write plus the byte to lock, because remember region 1 size is just the bytes to write, if that overflows the buffer, if it wraps, then we have to modify it. And this is just modifying region 1 size to basically be this thing right here again. So this is just putting it again in terms of this region 1, region 2. That is very similar to the way the Windows API does it. And so then region 2, of course, is the slop, right? Region 2 is kind of whatever is left over in a circumstance in which there is anything that's left over. So this amount, that whatever this is, if we're in this other case where we wrap. That's what region 2 is. So region 2 remember, region 2 always starts at the beginning of the circular buffer. There really is no other. If you have a region 2, it's going to start at the beginning of the buffer. That's how that goes, right? And then the region 2 size is just going to be whatever the total amount might. Remember, it's the slop. It's whatever's left over. So same kind of equation there. And so then now we've sort of figured out what our regions are looking like. Then we can figure out how many samples we're going to actually write. So that's just the size. So remember, region 1 size is in bytes, and if we take bytes divided by bytes per sample, we'll get samples. And then what we do is this sample out, right? That's just a pointer to where region 1 is in memory in the circular buffer. And so what we're going to do is we're going to write to that. We're going to start writing sound samples to that sample out pointer for the region, for as many samples as there are in that region. And so that's all this is. And this is exactly the same. This is just a condensed version, kind of a ternary expression of what we did to figure out which side of the square wave we want to be on. Are we in the positive side or the negative side? And that's all depending upon this half period, right? And our running sample index. And so then we spit out the two values for the channel, and we're done. And so that writes the square wave to region 1. And then if there is a region 2, right, starting from the beginning of the buffer, kind of what's left over, the slop, then we do the same thing, right? And that's it. And I can't believe that I actually got through this. And it's 11 o'clock at night, and I'm happy because so the big thing to understand now is we started off in this byte to lock kind of thing, right? And the byte to lock is determined by the running sample index, right? So however many samples we managed to increment, or however many samples in the square wave we managed to get to, that determines where we wake up in this circular buffer in memory. So that's a really important thing to note, is the running sample index only increases by the amount of sound that we're going to write. So let's say in this circumstance we start here, let's say we start some amount in on the circular buffer, and we determine that we last wrote here, okay, or that core audio last read something this far, okay, and we want to write to here. We're going to write that many, and as we're writing them, the running sample index goes up and up and up, so that the next time we wake up, this byte to lock is right here, and then we wrap. Okay, now this is not an example of as many samples as you would write. This is actually exaggerated, because in the real world it would look more like gosh. So in the real world, it would be more like these are going to be they're going to be a lot closer, right? So it would be some amount that's like a lot. They're just way closer in the real world, because core audio is not going to be able to read that many frames, or isn't going to read that many audio frames ahead. It's going to read some small amount. So the byte to lock will always be, will usually be some small amount kind of behind where the play cursor last got to, and so it'll kind of go up to there, and then it'll wake up, and the next time it'll wake up, it always wakes up exactly where it left off. So that's an important thing to note, is that every time, so you see these two things here, this running sample index plus, right? So whenever that's going on, what is that really doing, right? So whenever we're writing to this, whenever this running sample index increases, what's actually happening is this byte to lock, where we wake up next time in the circular buffer, is advancing. So we figure out how much we're going to write, and then this running sample index advances by that amount, and then on the next iteration through this run loop, we're going to end up right back where we were, and then we may end up wrapping around the circular buffer, or we may end up just writing a little bit chunk of audio ahead. So that's my explanation, and I'm going to build it and hope that we don't have it. So we don't have any compile errors. That's good. And I'm just going to make sure that this. So we're at day 11. and it plays. And gosh, this really this gets us quite a bit further. This gets us to a good place. There's a lot that we're going to change here. And I still admit that this is not perfect. Like I said, there's quite a few differences in terms of this API compared to the way that Windows does it. And Windows, you know, that might have a more accurate handle on where the actual play cursor is, because like I said, we're sort of like, if we think about this on the Mac, we're like a little bit behind the 8-ball on some sense. Maybe not, maybe it turns out to be okay, but it's just worth noting this, because if we're since we're managing our own circular buffer and we're not handing that over to Core Audio or to something else, like I said, all we know is, we're managing our own play cursor. So this is not representative of when the actual sound last, it's not representative of when the sound is actually coming out of the speakers, if that makes sense. It's representative of the last place where we left off when we fed some audio data to Core Audio, and like it's like the last index of the chunk of stuff that we handed over to Core Audio. It doesn't exactly represent when it's playing. Now it could vary. So the real question is then, in terms of time, right? And this is something I don't know because I can't really find any documentation. Obviously somebody can like kind of jump in, maybe help me out. What I don't know is what is the time difference between, like, what's the latency between when we hand off the samples to Core Audio and it plays, because that would be like the real play cursor, right? That would be telling us really in terms of time what our audio latency actually is. And we might be able to kind of adjust things a little bit for that. Maybe what we do is we decide that we're gonna, if we knew what that number is, we might pick a different number for our target cursor. We might have a target cursor that goes somewhere else. So this target cursor, like I said, is, it's some fraction of a second. So 533. It's some fraction ahead of where we last left off, right? And so it's some amount of time ahead of where we last fed samples to Core Audio. But if we really want to line up the sound with the actual frames of the visual frames of the game, knowing what that latency is between when we feed sound data to Core Audio versus when it plays, would help us hit the frame timing a little bit better, if that makes sense. And if it's really, really low latency, so the question is actually also just a matter of like the size of the latency. If the latency is really, really big, then we're kind of in a tough spot. I'm trying to curse a little bit less. we're in a pickle, we could say, because then it's just not possible to really hit the frame timing accurate. But if that latency is really, really small, then it's fair to say that our play cursor is actually pretty darn accurate, and that this is like good enough. And maybe I should also sort of add that this really depends on the type of game that you're making. If you're making a beat matching game like, I don't know, Crypt of the Necrodancer or something like that, or Beat Saber, whatever. In that circumstance, having very low audio latency is absolutely critical, and so you're going to want to know answers to these kinds of questions. It's going to really affect the quality of your gameplay experience. But maybe the kind of game that you're making isn't really one where the audio is super crucial, and you're willing to tolerate like a frame or so latency on the sound, in that circumstance, you'd be fine, right? So it really is just a matter of, it is a matter of knowing what the unknown variables are, but then in addition to that, also having some sense of what actual game that you're playing. So on another level, I don't feel super guilty like presenting this to you, because in spite of the fact that there are still some unknowns about it, it's enough to get you started. It's enough to sort of give you a sense of what you're doing when you're setting up a circular buffer for sound, how this thing actually works. So kind of like stepping through the code and understanding what that actually does. And more importantly, it hits my main goal of this series, which is to get you up to speed roughly around day 25 so that you can continue to follow the series and learn. So I feel pretty content in that respect. So I'm not really sure what's next. I think the next thing is like rendering sine waves, and then I think like there's a little bit of like one thing to kind of note is this square wave is like, that's really harsh. So in the next one, we're gonna probably spend a little bit of time, doing like a sine wave is just quite a bit more ear friendly. And then what we want to do is actually hook the sine wave up to the analog stick on the controller, because once you're tying the sine wave or the sound output to the actual controls, that alone gives you a better sense of how that latency feels. Because you'll know right then and there, just based on if I move the stick slightly in this direction or whatever, and have that change like the frequency of the pitch of the sound or whatever, you'll immediately get this kind of like sort of feeling about if the sound is late or close enough or whatever. And so far, my experience on the Mac has been that it's felt pretty good so far. It hasn't felt like too latent, but I don't take my word for it. You'll kind of have to do it for yourself and judge. So with that said, it's been another hour and 7 minutes. Thank you so much for joining. Please send me some questions if you have any. There's plenty of resources. I got a lot of this from the Linux tutorial, but then I sort of went over it again and realized that many of my assumptions were incorrect, and I just ended up kind of changing some of the ways that I do it. It's actually really similar to the Linux/SDL, but I think just the concept of like the right cursor was something where that was, right cursor, play cursor, that got to be, that to me didn't fully line up. And I went over it again today, and I was thinking to myself, something just isn't like correct here. And so, and I think it's this idea that, we don't really have a right cursor and a play cursor distinction here. Like we do this, we're just doing this very differently, at least when we're just throwing off some samples to core audio. So it's just a very different kind of a thing, and I wanted to present it in the least confusing way, and I finally got to a place where I wasn't as confused. So there you go. I'm sure I got a bunch of stuff wrong, and I'm sure that there's a better way to do it, but that's that, and I will see you next time. Also, support Handmade Hero, buy the game. It's like $15, best $15 you'll spend. And you can support me on Patreon as well if you would like to. I will just kind of keep doing this, and I will see you next time.